So we're going to be taking a look at the study guide for the next chapter quiz. We're going to start with the algebra problems and then work our way to the proof problems. So the algebra problems usually involve having a triangle or a pair of triangles that are congruent and then trying to figure out a missing variable using the properties of the triangle, usually the angle properties or the congruence properties. So the first one we have here, triangle BCA is congruent to triangle DFE, and we're given the pictures, and we want to find both x and y. So let's start with the x first. So when you're doing this problem, you want to first figure out, okay, where is one piece with my variable in it? So we see a 2x plus 7 right there. So we'll write 2x plus 7. So this is side BC. Okay. So this 2x plus 7 goes with this side right there. So it's side BC. I want to find out in this triangle over here, what's the side that matches with BC? Well, if that's BC here, that's the first two letters of this triangle, congruent to the first two letters of this triangle, DF. Well, DF is right here, and that goes with 5x plus 1. So I write 5x plus 1. These would be the pieces that would overlap if you put this triangle on top of that triangle. They would overlap, match perfectly, and therefore their sides have to be congruent as well. So this is what we mean by saying use the labeling to help you make your equations. So when you pick a side, write it down, write down the letters, and then look on the other triangle and think, okay, what position letters do I need? Here it was first and second, so over here I also need first and second. So that's where I get my 5x plus 1 from. And then now it's just simple algebra. You subtract 2x from both sides, so it's 2x, 2x. You get 7 equals 3x plus 1. Take away the 1. You get 6 equals 3x. And then you divide it all by 3, and you get 2 is equal to x. And then you're done. So once you get your equation set up, it's just simple algebra to finish it out. Excuse me. Now, the last one we need is y, and y is unfortunate because y is an angle, and if we look here, angles work the same way, but here y is an angle f, so 4y is equal to angle f. So angle f is going to match up with angle c. Go over here. Well, unfortunately, we don't know what c is. So we have to figure out what c is first before we can match up f with c. So let's figure out what we do know about this triangle. Well, we know that this is 80 degrees. If we knew what A was, we could do our 180 trick to get what C is. So let's figure out this here. So A is the last letter here. A matches up with E. So A and E match up with. Well, I know that E is 30. Therefore, if E is 30, that means A has to be 30 as well. So 3, 0. So now that I know that 80 is B and 30 is A, I can then figure out what C is using my 180 trick. Because remember, all three of these angles should add to 180. So I can do 80 plus 30, rather, plus, we'll say question mark here, because I don't know what C is equal to 180. Well, then we just do our little algebra here. So this question mark, that's going to stand for whatever C is. It's just like a variable. So I do 80 plus 30, well, that's going to be 110, plus question mark equals 180. So this is basically asking 110 plus what equals 180. Well, we know that the what there has to be 70, because 70 plus 110 would give me 80. So the only thing that could fit in here is 70. Well, now that I know what C is, now I can finish up this up here. So C is 70, so angle C is 70. That's going to match up with angle F, which is 4y. So angle F is 4y. And then now I can just divide both sides by 4. And I get 17.5 is equal to y. So in this case, you had to do a little bit of maneuvering to get C done first, because our first matching pair wouldn't work because we didn't know what C was. But once we figured out what A was using the second matching pair there, then we can do our 180 trick to get what C was, and then solve the equation through by setting up our solution here. Now, again, this one's a little bit more complicated because it involved two triangles and trying to figure out what pieces match together. The next three are basically just different types of rules for different types of angles and triangles. So like, for example, the first one here, or the second one here, rather, We have two inside angles and one outside angle, or an exterior angle. And the rule you have to remember here is that the outside angle is always equal to the sum of the opposite angles on the inside. So basically the angles that it's not attached to. So 17x minus 23 is equal to the sum of these two non-attached angles together. So it looks like this. The first angle, 8x minus 4, summed or added to the second angle, 3x plus 17, is equal to the outside angle, which is 17x minus 23. So again, it's inside angle plus inside angle equals outside angle. Inside plus inside equals outside. Inside plus inside equals outside. You can just repeat that to yourself to get it down if you need to. And again, the angles have to be not attached. So non-attached angles to this one. So I'm not using this angle at all. I don't know what it is. I don't really care what it is. It doesn't have any impact on me here. I'm using the two that are not attached to figure out the one on the outside. And then now we can do this with some simple algebra. So we combine our like terms. So that's going to be 11x, 8 plus 3. And that will be 13. 17 plus negative 4 is 13, because it's a negative 4. And I get 17x minus 23. Then we're going to subtract 11x. Subtract 11x. We get 13 is equal to 6x minus 23. We add 23. We add 23. And we get 36 equals 6x. Divide by 6. And we get 6 is equal to x. Just solving the equation through there. So the setup, once again, is inside plus inside equals outside. In, out. In, out. Okay. The next one here deals with a special kind of triangle. So this, let me draw a line here just to separate them real quick. This is an isosceles triangle, you know, because the sides are marked congruent. And the special thing about isosceles triangles is that the bottom two angles are always congruent. So this angle here is the same as this angle here. So you have a few ways of solving this. The simplest one might be this way. If these two angles are congruent, and this one is 9x plus 1, that means this one over here also has to be 9x plus 1. Well, now you have all three inside angles, 9x plus 1, 88, and then another 9x plus 1. So you can set up your normal everyday 180 equation. Say 9x plus 1, which is this angle here, plus it again, 9x plus 1, which is this angle over there, plus 88 equals 180. So again, it's first angle, copy of the first angle, because again, these are congruent, so they have to be copies of each other. And then plus the top angle is equal to 180. So make that a little bit cleaner there. And then now again, we're back to a normal everyday equation. So we add up our 9x's, we get 18x. Here we get, let's see, that's 2 plus 88 would be 90, is equal to 180. We're going to subtract our 90 from both sides. We get 18x is equal to 90. And then we can divide by 18. Whoops, 18 there. And we end up getting x is equal to 5. So once again, if you have an isosceles triangle, you're going to copy down basically one angle. One angle is going to be copied into the other one. And in this case, it's this one over here. The 9x plus 1 gets copied over here. Most cases, it will be the x because that's generally what they want you to solve for. But it's always going to be the angles that are opposite the marked sides. So if you're not sure what angle to copy, look at one marked side and just draw an arrow straight across. Look at the other marked side and draw an arrow straight across. These two angles that you're pointing to, those will be the copies. So 9x plus 1 over here with this arrow, it's going to copy to 9x plus 1 over here with that arrow. And then the 88 is just going to be by itself unchanging. The last one here for the triangle bits. This is just your normal everyday inside angle triangle. So you have all three inside angles. This one here, this one here, this one here. All three are inside the triangle. So you set up just like we did over here actually. You set up your 180 equation. 3x plus 11 plus 9x minus 16 plus 7x minus 5 all equals 180. So again, you have angle 1, angle 2, angle 3, all add to equal the total of 180. And then you can, again, solve it using your normal everyday algebra. Let me do a different color here just to add some contrast. So I'm going to add all my x's together. Okay. Here's 19x. You add all your non-x's together. So we have 11, negative 16, and negative 5. Well, negative 16 and negative 5, that'd be negative 21, plus a positive 11 would get you negative 10 equals 180. Probably should put this closer, but that's fine. We can add 10 to both sides. We get 19x is equal to 190. Divide 19, divide 19, and we get x is equal to 10. So this first set of 4 problems, again, is about the 4 rules we have for triangle angles, the 4 patterns. So we have your inside angle problem, right? That's the first type of problem. This is the first type of problem we ever did, actually. When you have all 3 angles in a triangle, they're all missing or they all have an x involved. You set them up you set them up added to each other and equal it to 180. So first plus second plus third equals 180 if they are all inside the triangle. Again, no outside angles, no isosceles trick, just a normal triangle, unmarked, all 3 angles inside. Add them up, you get 180. For the isosceles type of problem, this one right here, you have marked sides. You're going to copy down one of the angles. So it's kind of similar to this one over here, except you're missing one. You're not given one of the angles. One of these is going to be blank. But then you see, oh, I have marked sides. So you draw your arrows if you need to figure out which ones you're going to swap. So in this case, I put this one and put it over there, or copied over there. And then I can do my 180 trick from there. So I have first angle, copy of the first angle, and then the unique angle all added together to equal 180. And then up here, again, we have your outside angle trick. So this was, if you have an outside angle, you're usually going to have 2 inside ones, and it's just inside plus inside equals outside. Every time, all the time. So this is when you have an outside angle involved. And then you have the congruent triangles. This is when you have a pair of triangles, and they'll usually give you a congruent statement up top here. And that's when, again, you use the labeling to help you out. So you say, okay, this is BC. So first 2 letters, BC. What's that going to match with? Well, DF, first 2 letters over here. Then you match them up to set them equal to each other. There's no 180 we did in here. The only time we did 180 here was to figure out this missing angle inside here so that we can set up the equation for it down here. And you may not need to do that all the time. It's just that we had to do it in this one just so we can see the most complicated type of problem with this. But in terms of solving for x, there was no 180 involved. And same thing for y, there was no 180 involved. So this is when you set things equal to each other, not necessarily equal to 180. So now let's look at some of the proof parts. Okay. So the proof parts here, let me set my size there so hopefully it'll fit. So the proof parts, again, it's going to be look at the given statements and figuring out what we can deduce from that. So in this case, we have given 2 lines are parallel. We have L and M parallel, and we have C is the midpoint of BD and AE. We want to prove that these 2 triangles are congruent. Now, once again, you don't necessarily need to use every single thing in the given if you don't need to, and sometimes there's multiple ways of going about a proof. So just because this is one way that's been listed doesn't mean it's the only way. Now, this is a fill-in proof, so we have to kind of do it their way, but if you're doing it from scratch, again, there's multiple different avenues you can take. So to save ourselves some time, we should do this on the quiz with our own writing, but I'm just going to do this here for the given because we know that the first statement, whoops, let me try to do that a little bit better. So I'm going to take all the stuff here, and all of that is going to go in my given. So you would just rewrite all this in the given spot. I'm not going to, just to save ourselves some time here, but we know that. And then we also know that the proof statement, BCA and DCB, this right here, this last proof statement, this always goes last. This always goes in the last box. So I'm going to put that in there right away. I can't use the triangle key because there's no triangle button on my calculator, or sorry, on my keyboard. So I can just say triangle BCA is congruent to triangle DCB. So I know the first and last every time. First is always the given, last is always the proof statement. It's the middle ones I need to think about. So in this case here, it says BAE is equal to DEA. So let's figure out what those angles are first. So BAE So that's this one right here. BAE is congruent to DEA, this one right here. And our job is to figure out what reason do we know. Why is that true? What's the reason that goes with that? Well, if you have congruent angles, there's basically a few options. You can have vertical angles, you can have corresponding angles, you can have alternate angles, or you can have definition of a bisector. So let's run through those real quick. We probably don't have definition of a bisector because in our given, there was no bisector told to us. It didn't say that, this line bisects this angle. So definition of bisector is out. BAE and DEA are definitely not vertical because remember, vertical angles form that little X shape, and BAE, this red angle up here, does not form an X with that red angle down there. They're disconnected, so it can't be vertical angles either. So we're down to we're down to corresponding angles or alternate angles. Those are the only two things we have left. Well, corresponding is kind of hard to find, so we'll save that for last. But let's check if there's alternate. So alternate angles deals with the fact that we have parallel lines, which we do. And the way we figure out if they're alternate is if they form a Z shape. So what I mean by that is you start at one of these parallel lines. Let me start down here at L. So I'm going to start down here at L because it says L is parallel to M. So start right here. And I want to go up to M. So what I'm going to do is I'm going to travel down L. And then once I hit my transversal, so a transversal is a line that connects the two parallel lines. So this would also have been a transversal, but I want to make sure I hit my angle first before I cross. Otherwise, it won't show up. So I'm going to go down. I've hit my angle. Now the first transversal I come across, which is this one right here, this line connects my two other parallel lines. I'm going to go up that, hit my top line, and then go back down the same direction. So I was going down to the left, hit my angle, up the transversal, and then continue going to the left. If my angles are the corners of the Z, then they are alternate angles, and usually alternate interior. Well, in this case, this is this corner, that little red angle right there. I should probably make this a little bit on point there. So we have a little red angle in the corner there. We have a little red angle in the corner there. They're both in the corners of the Z, so they work. So we can say that this is true by alternate interior angles. Because remember, alternate interior angles are always congruent. The first time we saw alternate interior angles when we had this kind of shape here. We had that sort of half of a, or 3/4 of a hashtag shape, and we said that alternate angles were like this angle was congruent to that angle, and so forth. Well, this image is basically replicated here, just with a bunch of other stuff laid on top of it. That's why, again, this sort of Z figure here, so it works here as well. So if you go down here, up the transversal, over here, that's sort of Z shape or backward Z shape, depending on how you look at it. That's helpful to outline the alternate angles when there's a bunch of clutter involved like this picture here, because again, it just makes them stand out a little bit more. So we know that BAE and DEA are congruent. Why? Well, because they're alternate angles. And we could check the same thing for ABD and EBD. So let's check those. So ABD there, EDB there. Now it's looking pretty good that they're alternate angles, but let's just double check for sure. So I'll do M this time. So I'll start at M. I'm going to go down the parallel line. I've hit my angle. So first transversal I come across, which is this one right here, go down the transversal. I hit my other parallel line, and then I go the same direction. Keep going to the left. Well, my green angles are definitely in the corner. So angle, this one right here is in that corner. This one right here is in that corner. So that's the same reason. So I'll do my ditto marks here. So that's also alternate interior angles. For those of you that don't know, this is a ditto mark, which means take the reason above it, which just saves yourself some writing. So we have alternate interior angles for these two. We have alternate interior angles for these two, because again, they both form a Z pattern. And then we have something called definition of a midpoint. Well, let's see what that's here. So midpoint usually means what? Well, a midpoint usually means we have congruent segments, not angles. So midpoint is a segment type of reasoning. Well, let's first figure out where do we have a midpoint. Well, it says C is the midpoint of BD and AE. Well, C is right here. So it's in the middle of BD and AE. So we actually have two options. So in this case, you have one of two possible answers. So the first case would be, let's just take BD first. So C is in the middle of BD. Well, that means C cuts BD in half. So what you would say is that the first half of this line, B to C, so first to middle, the first half is congruent to the second half, middle to end. So BC congruent to CD. You can write that in here. BC congruent to CD. That could be by definition a midpoint because C is in the middle. Again, first half equal to second half. Or you could say the other one because it says it's also the midpoint of AE. Well, where's AE? Well, it's right here. So first to middle, A to C, is congruent to middle to last, C to E. So you could also say, if you wanted to, that AC, well, let me make that A a little bit better there, that AC is congruent to CE by definition of midpoint. So in this case, you have one of two possible answers. Either one of these would be correct, or both of them would be correct if you want to put them both down. Again, there's no harm in over-proving something, but that's just again, a possibility there. So as long as you have one of these two pairs, we're good. And again, deals with the fact that C is in the middle of both. So first half of one, second half of one, add them, or set them together and make them congruent. And then the last reason is given to us, AAS. If you didn't see that, let me mark my angles again here. So we have those two angles congruent, and we have these two angles congruent. So they're congruent by angle, angle, side, because if I pick one of these sides, let's say I pick the first ones I did here, so that one right there. So if I picked BC and CD as the one I put down here, I can see that I have angle, angle, side, angle, angle, side, so they're congruent by angle, angle, side. Let's check the next one here. So similar kind of picture, but now we have all the statements, we want all the reasons. Okay, so we're going to kind of go back and forth here. Well, we know that our first reason is always given, and our last reason all the way down here is going to be either angle, angle, side, side, angle, side, angle, side, angle. So it's going to be one of the five that we start with. Okay? So let's first figure out these reasons here, and then we can figure out our last proof statement. So the first one they say is AC bisects BCD. Well, this is a case where they actually split their given. So if you notice here, this is part of the given, and this is also part of the given. So in this case, they split it into two separate statements. So we'll do our little ditto mark here to save ourselves from writing. So these are both given. It won't happen all the time, but sometimes they do split up their givens. And then they say something new. So they say BCA is congruent to DCA. Well, let's highlight that. BCA, this one, is congruent to DCA, which is this one. Well, how might those be congruent? Well, again, if angles are congruent, we have usually four main cases: alternate angles, corresponding angles, definition of bisector, and vertical angles. Well, once again, they're definitely not vertical. They don't form an X shape, so we can toss out vertical. We don't have any parallel lines that are given to us. There's nothing in our given statement that says something is parallel to something. So it cannot be alternate or corresponding, because alternate or corresponding requires parallel lines to work. So if those two are out, the only one left is what we call definition of bisector. And that actually fits with our given, because we're in the statement here, we're given that AC bisects the angle. So we're given a bisector. Let me make that a little bit better there. In our given statement, so it would make sense that we use that definition of bisector in one of our reasonings. So again, it can't be vertical because they don't form an X shape, vert. So it can't be vertical, it can't be alternate, or it can't be corresponding because both those require parallel lines. So it has to be bisector in the end. Now then here they say AC is congruent to AC. Well, how is AC congruent to AC? Well, if you see the same thing twice, the exact same statement, whether it's a side or an angle in this case, if it's the exact same statement, letter for letter is congruent, letter for letter, then it's always going to be reflexive. Reflexive is how you say something is congruent to itself. So here they say AC, this line right here, is congruent to itself, so you can mark that down with a dash. And the reason they do that is because it's shared. Shared pieces are always said to be congruent because of reflexive, and they give you kind of a free side in each triangle, so they're really nice to have. Now, one thing we didn't mark down, which we probably should, is this little given statement here, BC congruent to DC. So it says up here BC congruent to DC. So we'll mark that BC congruent to DC just to make sure we have everything marked. Because our last thing here is saying, okay, how are these triangles congruent? Well, to prove triangles congruent, we have one of 5 cases, right? We have side, side, side. We have angle, angle, side. We have side, angle, side. We have angle, side, angle. And then we also have hypotenuse leg. Let me shorten this up here a little bit. So these are the 5 possible cases we can have to prove 2 triangles are congruent. It has to be one of these 5 cases. Well, let's go through them. It can't be HL because HL requires right triangles. You have to have a right angle in order to have HL. We don't have a right angle anywhere in here, so that's out. Angle side angle requires 2 angles. Well, I only have one angle pair here. Again, this is an angle pair, not just 2 separate angles. So these 2 angles match together. That's one angle pair. I need 2 angle pairs. I don't have 2 angle pairs, so that's out. Side angle side requires 2 sides and then an angle between them. Well, I have 2 sides, and I do have an angle, and it looks to be between the 2 sides. I have a side, angle, side. So I have the angles between my 2 sides here, and I have the angle between my 2 sides there. So this seems like it's going to be a good possible case. Let's just check the other ones just to make sure that we're not overlooking something, though. But this seems like it's going to be pretty good because it fits with what my picture is, which again is why it's good to mark down your stuff as you go through. Angle, angle, side requires 2 angles again. I only have 1 angle pair, so that's one's out because I need 2 angle pairs for that one. Side, side, side requires all 3 sides matching. Well, I have 1 side matching. I have 2 sides matching. Again, this is talking about pairs. When I say a side, I'm talking about a side pair. So excuse my language. And then I need the 3rd side pair, which I don't have. I would need AB congruent to AD. I would need this side pair to be matching, which I don't. So it can't be side, side, side. So the only one left then is side, angle, side, and that's what I'm going to write down. Side, angle, side. So once again, when you're given a reason blank here, the first reason is always the given. The second reason could be the given if they're splitting it up, so make a check for that. Otherwise, again, we have definition of bisector for this little keyword there, and then we have reflexive for the shared piece between them. So always look for your keywords in the given statement, and always look for reflexive and vertical angles in the diagram, because those will help lead you into what you're trying to construct. So last one here is a from scratch proof. So we're doing this all on our own here from scratch. So let's set up our 2 columns real quick. I'll give ourselves a few columns here. I'm not sure exactly how many we'll need, but we'll just give ourselves a few. And hopefully I'm going to make these large enough that I can actually write stuff in. There we go. So let's extend this a little bit more. There we go. So this should be enough. Let's see if it holds here. So I will do a shorthand for the given, so I will say given here, because we always know given is going to be our first statement, and I'll just put a little squiggly here. So everything in here is given to us there. So now we're going to embark on a little proof journey here. So before I even touch my given, let me just look at the triangles and see, is there anything that stands out? Well, if you look carefully, in the little middle column here, I have that sort of X formation that we've seen before. So I know that I can probably get some vertical angles out of this. So what I'm going to do right here is I'm going to write down vertical angles, vertical angle theorem. Or you can say definition vertical angles. That's fine too. And so I'm going to say, okay, if I'm looking for vertical angles in that center picture there, which ones do I want? Because I have basically 4 sets. I have the top 2, and I have the left and right. So I have an angle, I have a vertical angle top and bottom, and I have a vertical angle left and right. I want to know which pair do I want. Well, I would prefer the ones inside the triangles, because I'm trying to prove the triangles are congruent. So I'm probably going to want this angle here, and this angle here, this little bow tie shape. So how do I call those angles? Well, this one right here is angle BCA, because again, I want this corner. I want the angle in this little area. So C has to be my middle letter. So it'd be angle BCA for the left one is congruent to angle. So for this one over here, I want ECD. So angle ECD. So then I have my vertical angle set, so that one's done. So again, always look for vertical angles first and then look for reflexives. And unfortunately, we don't have a reflexive piece, so we can toss that one out. But I did have a vertical angle piece that I wanted to get down first before I try to use my given in any way. So now we can go back to the given and see, okay, what can we tell about this? Well, the first thing here is that these little perpendicular things there. So AB perpendicular to BD and BD perpendicular to DE. Perpendiculars give you a lot of information because they tell you that these angles, or these lines intersect at right angles. So AB and BD intersect at a right angle right there. And same thing for this one. BD and DE intersect at a right angle right there. Now, not only do I know that they are right angles, but I also know that they're congruent because all right angles have to be congruent. But you have to say it in two steps. So if you're given a perpendicular thing in your given statement, you're going to take 2 steps with it in most cases. And here's how it's going to go. I can say that angle B and, that's the and symbol, angle D are right angles. So angle B and angle D, this is the angle symbol, remember, are right angles. Why? Well, it's because definition of perpendicular. You can put the symbol for perpendicular if you want to, which is that upside down T. So perpendicular says they're right angles. It does not say they're congruent though. So what we're going to do is our next step is now we're going to say angle B is congruent to angle D. Why? That's because of the right angle theorem. So the right angle theorem says if the angles are right angles, then they have to be congruent. So we state here first, hey, these are right angles. That's our first statement. Why? Because of this. Then our second statement is, hey, they're also congruent. Why? Because of this. So you can't go straight to here. You can't say angle B is congruent to angle D because of right angle theorem. Because first you say, hey, perpendicular lines, they're right angles. Now you say, hey, now that they're right angles, I know that they're congruent because of right angle theorem. So these two usually go back to back in most proofs. So if you see a perpendicular symbol, you're probably going to use this in some way. Not every time, but in like 90% of the cases, you're going to be using this back to back. Right angles first, then congruent. Definition of perpendicular first, and right angle theorem second. Now we're pretty much almost done here. Again, our goal is to get one of those 5 cases. Side, 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 angle, side, angle, 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 side, side, angle, side, and HL. These are the 5 ways we can prove 2 triangles are congruent. The 5 ways we can prove that statement. So let's see where we're at right now. We have 2 angles and no sides. Well, if we have no sides matching right now, SS is probably out. And SAS probably out as well because that needs 2 sides. Well, if we have none, we're probably not going to get to 3 or 2. But we still have some contenders in here. This one, ASA, that requires 2 angles, which I have. I have 2 angle pairs matching between the triangles. And this also requires 2 angle pairs, which I also have. So these two look impossible. And even HL, because remember, HL requires a right angle to work. And in this case, we actually do have 2 right angles. So all 3 of these are still possibilities right now. But they require some sides. So I need to get an S for these, and I need to get the hypotenuse and leg for this. Remember, the hypotenuse is the angle opposite, or sorry, the side opposite the right angle. So the hypotenuse in this triangle, if you take your right angle, would be right here. So this is the hypotenuse for this one, and then across the right angle, this is the hypotenuse for that one. If I can get these matching, then I'd be closer to getting hypotenuse leg. So this one's going to be a little bit more difficult in our situation, but still possible. But either way, I need a side. Well, luckily I have one more statement in a given that I haven't used, and that's this one right here. C is the midpoint of BD. Midpoint, thankfully, is used to give me congruent sides. So let's see where that is. So C is right here. That's in the middle of BD. Well, that means that the first half, B to C, so let me do this one right here, B to C, is going to be congruent to the second half, C to D. Because again, if it's in the middle, that means first half is over here, second half is over here. They're both halves, so they have to be equal to each other. So if this entire thing was 10, BC would be 5 and CD would be 5. Because again, C is in the middle, so half there, half there. So I can say that. I can say that BC is congruent to CD. Why? Because definition of midpoint. I'm doing my best to write with my mouse here so that you can read it, but please forgive any sloppiness. So now I have a setup that I can actually work with. Because if we look here, I didn't quite get HL because I did not get this side over here. So I can say that HL is done now. Okay, I don't have this hypotenuse here. I don't have this hypotenuse there. That one's done. These are still two possibilities because they both require two angles and a side, two angle pairs and a side. And I have each. Two angle pairs, 1, 2, and a side pair that I just found. So which one of these is it? Which one of these matches this picture here? Well, here I have an angle, a side, and another angle. Oh, let me make the A a little bit better. So angle. And over here I have an angle, a side, and then another angle. Keep making my A's a little bit less. There we go. So this seems to imply that I have angle, side, angle. Why? Well, because my side is between the two angle marks rather than outside of it. Angle, angle, side would require something like this. If I have a triangle here, angle, angle, side would be you have this angle matching, and then this side over here. This would be angle, angle, side because the side's not between the two angles, but in this case it is. So what I can say for my last statement here, which I need one more little row here to finish this out, so it's off by 1, is I can say triangle ABC. Again, your last statement is always your proof statement every single time. I'm going to rewrite exactly what's up here. Okay? Every time, all the time. EDC. Why? Because of angle, side, angle. So a little bit of a long proof, I know, but again, you're trying to use the keywords in your given to figure out which one of these 5 will work. So first we use the vertical angles because that was given in the picture. We saw that, we got that down first so we didn't forget. Then we used perpendicular for a pair of statements. First to say that the angles are right, and then to say that they're congruent, which often happens with perpendicular lines. You have 2 right angles you're getting, and then you have 2 congruent angles after that. And then we use the midpoint to get our side, and we found that we have, at the end here, we had an angle, a side, and then another angle, and the same thing in both triangles. So we finished it off with angle, side, angle at the end. So that's it for the study guide video. Again, remember your triangle rules that we did at the very first beginning there, so you can set up your equations correctly. And then for proofs, again, read your given statements carefully, use those keywords, midpoint, bisectors, perpendicular, parallel, so you know what to expect. Again, parallel lines give you angles with alternate and corresponding. Perpendicular lines give you this little setup here, right angle and then congruency. And then of course your midpoints and bisectors will give you stuff as well. That's it for this one. Hope you enjoyed the video. Have a good day.